For today's advanced concepts presentation, I will be talking about the alpha helix. The alpha helix is a secondary structure of a protein. A secondary structure refers to the regularly folded segments of polypeptides in a protein. This folding pattern is created by hydrogen bonds. Secondary structures in proteins were discovered in 1951 by Linus Pauling and Robert Corey. Today's focus will be on the alpha helix. The overview of this is that I will discuss the alpha helix and the electrostatic forces that hold it together. I'll also propose that isoleucine could replace the leucine zipper. After that, I will talk about what residues would destabilize the core of the alpha helix. Then I will talk about alternative amino acid pairs that interact similarly to lysine and glutamate. And last, I will name two examples of substances that have alpha helix proteins in them. So here's the alpha helix structure, and it's shown in 3 levels of detail. So we can see here that the alpha helix is a rod-like structure with a very tight coiled backbone. As we keep looking, the levels of detail increase, and here you can see that the backbone contains carbon, oxygen, and nitrogen, and that is tightly packed in this coil, and that the side groups extend outwards from the backbone. So, how is the alpha helix stabilized and held together? Well, it's stabilized and held together by hydrogen bonds between the amine group and the carbonyl group on the main chain. Each residue is related to the next one, and residues that are spaced 3 to 4 spaces apart in the sequence are close. In fact, they're closer than those that are spaced 1 to 2 spaces apart. Here you can see that the residues that are spaced 1 to 2 spaces apart are actually on opposite sides, so they couldn't bond together. But we see that these arrows are pointing to the fact that those residues that are spaced 3 to 4 spaces apart do, in fact, bond, and that creates the helical structure. So next, I would propose that isoleucine could replace the leucine zipper. I say that because one objective would be to maintain the hydrophobic interior of the helix. The isoleucine has an aliphatic side chain, which we can see right here. An aliphatic side chain that is nonpolar, and that would keep the integrity of the hydrophobic character. So what would destabilize the core of the alpha helix? There are many factors that could do this. First, steric clashes. That is, side chains that are bulky, that would take up a lot of space or modify the shape of the helix. Amino acids that have bulky side groups include valine, threonine, and isoleucine that I did reference before, but the isoleucine would still be a good replacement for the leucine because of its aliphatic structure. Next, another factor that could destabilize the core of the alpha helix would be competition for the amine and carbonyl groups on the main chain. That competition could come from amino acids like serine, aspartate, and asparagine. They have side chains that have hydrogen donors and acceptors, and that would compete with the amine and carbonyl groups that are already trying to bond. Last, we could see some helix breakers. One of the helix breakers is called proline. Proline does not have the phi fit. When I say that, I mean phi referring to the angle of rotation between nitrogen and the alpha carbon in an amino acid. Proline does not have an amine group, so it would not be able to achieve that 5 fit. In fact, it would bend the helix if it did want to replace that the core of the alpha helix. So some alternative residue pairing could be between aspartate and arginine. That's because aspartate has a positive end and arginine has a negative end, and those two will attract and interact to create a bond, just like the lysine and glutamate did in the example in the assignment. Last, the two examples I found about substances that have alpha helix proteins in them are hair and skin that we are all familiar with. So it's interesting to see the real life application of alpha helixes or alpha helices. Thank you for listening. Have a good day.